feed more concept into your brain. Now you're going to titrate a mixture rather than just one chemical, one titrant, one analyte. Here you're going to have two analytes. So let's say this case is that your titrant is a reducing agent. Then you're going to have two analytes in the oxidized form. So one is reducing, and another one is going to be reduced from the oxidized form. And then you calculate the delta E for the reaction to prove that the reducing agent is strong enough, right? So you must prove that so that you will have two reactions. Okay, so that is the first step. Now you have two reactions. Then which reaction is going to go first? So that is which analyte is going to be titrated first. Okay, so what it means is that you're going to have two endpoints. So here is the general guideline. If you have a delta E between the two half reactions here, the delta E is at least 0.2 volt, then you're going to have two endpoints. Okay, so this is what you determine first, how many endpoints. Then you determine which one is going to be titrated first. Okay, so looking at the two half reactions. So you have two analytes in the oxidized form. So let's say this is one half reaction for one analyte. Well, here is another half reaction for the other analyte. So looking at the two half reactions, which analyte you are looking at in the oxidized form. So this is in oxidized form. This is in oxidized form, right? So, excuse me, these are in the reduced form. So we will switch here. So the example is reducing agent, oxidized analyte. And here my example is the other way around. So the titrant is oxidizing agent. So you will be looking at analyte in the reduced form. And this would be your analyte. Okay? So reduced form, so oxidized by the titrants to form that. Then this one also in a reduced form, so your analyte is going to be oxidized by that. Okay, so now by looking at these two in a mixture, so you have these two analytes in a mixture. Are you going to have two endpoints? Well, first of all, this is strong enough to carry out a complete reaction with this guy, as well as with this guy. Okay? So now the difference between the two, difference is not ratio we are talking about, it's just simply difference. Okay? So the difference is obviously greater than 0.2, and therefore you're going to have two endpoints. Okay? So remember, previously, the pH endpoint titration, then that was based on the ratio of Ka. And here is based on the difference of the two potentials. Okay? So memorize that. So you're going to have two endpoints. Okay, so let's switch an example. So you're looking at these two half reactions. Okay, so this is a redox reaction. So if you pick a strong oxidizing agent, so you're going to titrate against your analyte in a reduced form, right? So the two half reactions only give you information. That's what you may analyze for, okay? So here, you're going to determine the reduced form. So the Fe2 plus, you're going to employ this half reaction. The analyte is going to be this. Then for titanium, the analyte is going to be that in the reduced form. So the complete reaction then will oxidize the Fe2 plus in the Fe3 plus. Okay? Any question about that? So you're looking at this and this as a complete reaction. Then you're looking at this and that as a complete reaction. And both reactions will give you a positive value of E overall. And therefore, the reactions will go. Any question about that to begin with?
What if the E overall is 0?
Then you need to incorporate the potential of this guy. Remember, that's plus 1.5 or so, plus 1.5. So plus 1.5, and switch this guy minus 0.7, so plus 1.5, add to the minus 0.7, so you get an overall of a plus. Yes?
So in the solution you have Fe2 plus and Ti3 plus, right?
Okay, these are two separate half reactions.
But you have them in the solution, and then you add them in.
Right. So for this particular titrations, you will be able to look at Fe2 plus and Ti3 plus in the reduced form, not the oxidized form. You cannot use oxidizing agent to oxidize further.
Oh,
okay. So for the complete reaction, this stay in its own direction in a half reaction, then these two must be switched, right?
And so if the difference between the Fe2 plus and Ti3 plus is more than 0.2, it's going to have two different endpoints.
That is point number 2. Point number 1 first. Can you see that this has to be like this in order to proceed with the titration? So that's step number 1. Can you see that? Right? So there's a strong oxidizing agent. It's going to oxidize your analyte, right? So looking at this two, which one is going to get oxidized? Of course, the one in the reduced form. So this becomes your analyte in your sample solution. Okay? Similarly, if you're looking at this half reaction, okay, so this oxidizing agent is going to oxidize the reduced form of the chemicals. So which one is a reduced form? It is this one, right? So if you write the complete reaction, then you realize that, well, for the half reaction of this, it's going to stay in its position, its direction, just like the table. Okay? Then for this one, it's going to switch, right? So when this is switch, then this is going to be minus instead of a plus. Okay? So this one stay its position, then it was a plus 1.5, and this one switch its direction, becomes a minus 0.77. So now the overall is the two combined. E overall becomes a positive value, so the reaction is spontaneous, right? So that is what we covered last time. Okay? So for now, I expect that you'll be able to realize, and see this indeed should be the case. Okay? So now this constitute complete reactions. Then look at the mixture. Okay, both of them the two reactions will go, then which one will go first? Well, here indicate this guy is going to get oxidized first, simply because when this is switch, right, when this is switch direction, then a minus 0.1. If this was switch the other direction, this is a minus 0.7. So which one is a higher magnitude in terms of the minus? okay? So that means this one, the minus is less than this one. This one is minus more. And therefore, the minus less than your E overall, right? The E overall, the plus magnitude will be greater, right? Simply because this minus is smaller than this minus, right? Imagine this is a plus 1.5. Add the minus 0.1 versus plus 1.5. Add the minus 0.77. Then of course this E overall will be smaller, right? I mean, the E overall would be higher because of smaller difference, right? So this one will go first, right, Jeffrey? Right? Agree with it?
No, it doesn't matter if I agree or not, it's just,
Oh, then you memorize it.
no, it's the way it is, right? It's just how
Oh,
it is.
no, philosophy speaking. Yeah, it's true. I mean, I admire your philosophical thing. That it is true. Sometimes I think of myself, why am I here? Why am I King A? It's Jeffrey, you know. So, yeah, things like that. The why is interesting. Yep. Okay, so because the lower minus, okay, and therefore that's the reason.
Why are you? I don't understand why you're doing that. The switch lower, minus higher.
Well, first of all, from previous lectures, right? What is a spontaneous reaction?
Well, I guess spontaneous is when
Yeah.
it's
Okay.
Right?
Okay. So you must switch, right? When the direction of this, to combine with that to form a spontaneous reaction. So now, once you switch, right? Once you switch, then you look at the E overall. So now, as this will be switched, then this one stay. Then you will see that when this combined with this, then the E overall is a higher positive. And therefore, this one should go first because it's
Oh,
a
so
higher.
you're determining which one goes first. By doing
Yeah,
that.
that's
Oh,
right.
okay.
That's right. Because this is a mixture. So your titrant is going to consume which analyte first. Okay, and that is important, right? Because these two, the quantities could be different, and therefore this will be consumed reacting with that first before reacting with that. Chris.
Even if you use like a real expensive instrument, you still kind of get a difference between the two endpoints if the delta E is less than 0.2.
Well, yes.
You go.
Yeah, if you use a fancier instrument,
You go.
So this here, the two endpoints deal is based on the usual visual determination, just like the pH endpoint detection is based on color change. So here is going to be a titration as well for the delta E. So if you use a real noise-free instrument, then you get a little tiny dip. Still, there are two dips. Yeah. Okay. So any question with that?